I have room on there. What do I first plot when I go to, I'm trying to plot f prime. If my f is sine, what do I first plot? Where do I start? What are the most important points to start with? I'm trying to plot the slope. Anchor points, which is where the slope is 0. Slope is 0 here. What point is this? What point? Where does sine become the biggest? Pi over 2. So what's this? Negative pi over 2. I like it. What's the slope here? The slope here, we were just arguing earlier that it looks like it's 1. And what's the slope in between? It's positive. The biggest is right there, because then it starts to turn back. What am I graphing? What is that? That's cosine. So geometrically, that's an argument that the derivative of sine should be cosine. And there's the algebra, the computational part behind it. I like it. So in much the same way, so now I've got, if y is sine, y prime is cosine. That's beautiful. So what do you think should happen about cosine's derivative? So here's cosine. Right? So here's pi over 2. So I would start by plotting its 0 points, right? And what is the derivative here? Is it positive or negative? Negative. And it seems to be biggest going through here. So am I plotting sine right now? Here it's positive and then going smaller, so it's going to be like this. This is where it's the biggest positive slope, and then it goes back down. Is that sine? No, it's what? It's negative sine. It's just flipped. So then given y equal cosine, its derivative ends up being negative sine. These are very building blocks. So now we finally have like 3 functional rules. We have x to the n, power rule, and then we have the basic 2 trig parts. Every other trig function builds on these, right? So I should be able to use the rules I know to build other derivative rules. So how would I do, for example, tangent? How is it based off of the ones I know already? Sine over cosine. All right, take a minute and figure out its derivative. What rule are you going to use? Holy shit, all right. This is what I said earlier. When we learn more function-specific rules, and we learn these higher-level product, quotient, chain rules, together we can then figure out what other functions are, because functions do build on each other very often, especially trig functions. Holy shit. They're all just different ratios of sides of triangles. So they build off each other. There's the rule, right? Top first. Derivative of sine is cosine. So cosine times cosine is cosine squared. Derivative of cosine is negative sine. So here's a trick, not a trick, but we haven't done the other ones yet. All the co-shit derivative is negative. That's kind of beautiful, which gives you a better feel for why we call them the cos, right? So all the co stuff, cosecant is going to equal negative something. Cotangent is going to equal negative something. That's kind of nifty. Cosine equals negative sine. So negative sine says negative sine is positive sine. Oh, look at that shit. What's the top? 1. And what's 1 over cosine? Secant. There we go. So the derivative of tangent is secant squared. That's another rule we know and that you must memorize. Now take a few minutes and do the rest of them. Figure out what the derivative of cosecant is, secant, and cotangent. Go ahead.